Alright, so now let's go over this. This is in class exercise number 2. And what I'm looking for you to do in these first few problems is to convert these line structures into chemical formulas. So basically determine how many carbons, how many hydrogens, and so on are in each of these molecules. So recall that we said that we find our carbons by each spot that lines come together. So, such as here, each of these spots that I'm highlighting in yellow. So you can see we have a total here of 6 carbons. Now, what order do we list the elements in? This is actually pretty straightforward. We list carbons first, then hydrogens, and then any other elements go in alphabetical order. So we'll put our hydrogens next, and then the only other element that we have here are oxygens. I'm just going to go ahead and do the oxygens because those are easy because they're, as we said, they're just always drawn in. So 1, 2, 3, 4, 5, 6. So the tough part is always going to be the hydrogens. So we can see 4 hydrogens pretty easily. Those being the ones that are on the oxygens. But what about others? Well, in that case, we're going to have to look at each carbon and determine what's on each carbon. So this first carbon here, you can see has a double bond to oxygen, single bond to oxygen, and single bond to carbon. So it already has 4 bonds. Since it has 4 bonds, there is no hydrogens. And the same thing can be said for these 2 carbons. They each have a double bond and 2 single bonds. But now if we shift over to this carbon here, we can see that this carbon has a bond to oxygen, a bond up to this carbon, and a bond over to this carbon. So it has 3 bonds. So it has to have 1 more for 4, so 1 hydrogen. This carbon, same thing, we can see it already has 3 carbon-carbon bonds drawn in. So there has to be 1 more for a hydrogen. And finally, this carbon, we can see has 1 bond here to carbon, 1 bond to oxygen. That's 2 bonds total. So to get to 4, we have to have 2 hydrogens. We can add that up, and we get 8 total hydrogens. A couple things to note about that number of hydrogens. If your molecule only has carbons and oxygens in it, other than hydrogen, then your number of hydrogens is always going to be even. You're really only going to see odd numbers of hydrogens when you start adding in elements like nitrogen. All right, let's move on to the second example. So first question, of course, how many carbons? You can see I'm labeling them in red. We have 8 total carbons. Now, this first carbon that I'm going to highlight in yellow, I've put this one in yellow because it has 4 bonds to it already. And since it has 4 bonds, it has no hydrogens on it. Now, do we see any carbons that have 3 bonds? It's this one right here. That carbon has 3 bonds. Or we should say 3 bonds that are drawn in, which means the 4th bond has to be to a hydrogen. What about carbons with 2 bonds to other carbons? Well, we have one of those right here. 2 bonds, therefore 2 hydrogens. And finally, these last 1, 2, 3, 4, 5 atoms all have 1 bond only, and therefore they have 3 more bonds that are hydrogens. So how many total hydrogens? Well, we have 5 carbons that have 3, 1 that has 2, and 1 that has 1, for a total of 18 hydrogens. And so that gives us our chemical formula here, C8H18. And so this is the way we can go through with each of these molecules and convert them from a line structure to determine the number of atoms that are present. Now notice the next example does have a nitrogen in it. And typically if we have a single nitrogen in a molecule, that's when we can end up with odd numbers of hydrogens. So again, we can count up the number of carbons. And we have 6 total carbons. Again, I can do the nitrogens and oxygens. Those are easy. There's 1 nitrogen and 2 oxygens. And again, it's the hydrogens that are the most complicated. So of those 6 hydrogens, I'm going to use the same colors again. Which carbons already have 4 bonds? That would be that one there. Which ones have 3 bonds? That carbon has 3 bonds, and so does that one. So that's 1 hydrogen for each of those times 2. Are there any carbons that have 2 bonds? We have this one right here. So that has 2 hydrogens, and there's 1 of them. And then finally, we have these 2 carbons, which so the 2 carbons, each with 1 bond, which means they have 3 hydrogens. So if we add these up, you can see we get 10 total hydrogens. But can't forget, these hydrogens, the ones that are on the nitrogen and oxygen. Those are just as is, so there's 3 more, and we end up with a total of 13 hydrogens. And we can go through the same step-by-step thing with number 4, highlighting our 8 carbons. Again, 1 nitrogen, 2 oxygens. And so then it's just a matter of counting up the hydrogens. 3 here, 1, 1, 1, 1, 1, and 1 here. And so 9 total hydrogens, and you can see again, having 1 nitrogen meant we ended up with an odd number of hydrogens. All right, finally, these last 2 questions, I'm saying there's something wrong with them, and I want you to figure out what's wrong. So in this first one, the issue is the nitrogen. Nitrogen should have 3 bonds. This nitrogen only has 2. Our second structure, the error should be even more obvious. We have a carbon that has too many bonds. Again, remember, carbon always has 4 bonds. Not 3, not 5, not 6. And certainly not, as one of my students did on an exam in 2011, please don't draw 17 bonds to carbon.